So, to introduce the concept of combination, let me start with the following example. How many different pizzas can be ordered with exactly 2 ingredients from the list: pepperoni, ham, pineapple, and mushrooms. Well, it's not so important the ingredients that we have, but really the number of elements that we have here. So, in other words, the question is, can be rephrased in the following: how many subsets of 2 elements are there in a set that contains 4 objects? Well, this is small enough so that we can do this by hand. So, well, let me use not the first letter, but kind of a code for this. I have my original set P, H, let's say N, and M. Let's see if we can count them. So I can pair P with H, I can pair P with N, I can pair P with M, I can pair H with N, I can pair H with M, and I can pair N with M. So the total number of different orders is 6. But now this introduces the following more general question, and that we need to resolve. How many subsets of R elements are there in a set containing n objects? We're gonna give this a name. We call this number C N R. So, for example, we have that C of 4, 2 is 6. Now we know a few. For example, C of 4, 4 must be 1, because to select 4 elements from 4, well, there's only one way: you pick them all. For example, if I write C 4, 0, well, I have 4 objects, and from there I pick none of them. Well, there's only one way: you don't pick them. So that's 1. Let's explore just a few. So C2, 1, what should be this? Well, I have 2 things, and I need to pick one. Well, there's 2 ways to do this. One more. If I have C of 3, 1, well, that must be 3, because if I have 3 objects and I want to pick one, well, I have 3 different ways of doing that. Now, what matters now is finding a better way to compute this number, which we will do in a moment.